Welcome to Unit Testing View Apps. We'll go through some tips, tricks, and best practices. In case you would like to follow along on your own, a copy of my slides can be found at tinyurl.com/viewconf-unit-testing. So the first half of this talk will be agnostic to your tools, and the second half will dive into the tools that we've chosen at Lob, which are vtest, viewtest utils, and testing library. We'll go through why we want to unit test. Okay, one second. Is that better? Cool, okay. Sorry. Okay, still good? Okay. So we'll talk about why you want to unit test, what to test, and then how to actually write those tests. As an introduction, my name is Beth Chung. I'm a senior software engineer at Lob, a company with the goal of automating the sending of direct mail, which is an interesting industry to be in. I'm also a resident of Denver, Colorado, a rock climber, hiker, general mountain enthusiast, and dog mom to the most precious creature on this planet, but I might be a little biased. All right, let's dive into it. So, why do we want to unit test? The first reason would be to document behavior. Have you ever looked at a chunk of code and wondered what it's supposed to be doing? You can refer to the unit test to figure out what is supposed to happen. The second reason would be to verify requirements. Once we've figured out what it's supposed to be doing, does the thing actually do what it's supposed to do? It also provides a safety net. It makes it a lot less risky or easier to rewrite or refactor pieces of code. You should hypothetically not even need to edit or change if you are not editing user behavior at all, and your test should still pass. Hypothetically speaking, of course. It also provides quick feedback if you've broken something while adding or changing code. The last reason would be to write better code. If you find that what you're writing is too hard to test or too complex, that might be a good indicator that you want to split your code up or break it down a little bit more. Cool. A common question I hear a lot is, what am I supposed to test in a browser? The same answer applies for kind of regardless of what you're testing, which is inputs and outputs. This seems a little bit more nebulous than testing something like an API. For an API, you get some parameters, you do some stuff with it, you send a response back to the browser. Your input is those parameters, your output is what you're sending back to the browser. But in the front end, that's a little bit more vague. And so I like to think of inputs as what are the things a user can see or do, and then outputs as the results of those. So for example, a button would be an input, and then an output would be on that button click, something should happen. Things that you probably shouldn't test, even though you may be tempted to, are API return values. If you control your API, it should have its own tests. If you don't control your API, it should still have its own tests. External libraries, you don't want to be testing Axios or components from a UI component library. Lodash, anything else you may be using. The TLDR here really is just use APIs and third parties that are well tested in and of themselves. And that makes your life a lot easier. The other thing you don't want to test is implementation details. If a user takes X action, prop/data field Y changes. Instead, again, we should be testing what should the user see or do, not what sort of state does our component hold. So for example, you don't want to be testing when a user types a name, the component's data field updates. Again, that would be testing implementation. Instead, what you could test is when a user types a name, the text input shows the name that they typed. This may be controlled by your component library, and so if you are doing that, hypothetically, that should be tested by your component library. Another test you could do to verify that the data field is updating as you wish is when the user submits the form, an API call is made with the name as a parameter. So unit tests should be kind of self-contained entities. We don't want to be testing entire flows. So for example, a user opens a form, a modal pops up, they input some stuff, they click submit, and then they get taken to a different page. That's what integration tests are for. You are writing integration tests, right? It makes it very hard to figure out what part is failing if you do a test that is kind of goes through all of that. Instead, you could have a unit test that tests that a modal renders with an input for a name or anything else. A button to submit exists. When the button is clicked, the API is called, and when the button is clicked, the modal closes. Awesome. All right, let's move on to how to actually write these tests. So I've created a demo app, which is kind of a fairly stripped down version of Lob's customer dashboard. Instead of our API, I'm using a dog API because why not? This app uses Vue 3, Pinya, and Tailwind CSS. Let me switch tabs. Cool. This is our homepage. It's fairly basic, just some text on what it's supposed to be. We're going to mostly ignore this page. So we've got a list of, so before actually we get the list of images, we have a loading indicator while responses are coming back from the API. Once we receive those, we have a table with a picture of a dog and then the breeds. At the bottom here, we have a pagination component that shows how many total results and what page we are on, and then lets us go to another page. When we do, the URL changes to update the page, and then we will go into an American Eskimo dog. Once we click on a row, we see the image ID, a larger version of the image, breeds again, and then we have buttons to favorite. If it is already favorited, the button will be red. There's a favorited text. You can delete a favorite, and you can upvote and downvote. And then the buttons change color appropriately, and the text also changes. So that's our pretty brief demo. Let's go back here. Cool. So as kind of an overview of our app structure, we have API modules for each group of endpoints that our application uses. Our components consist of the details row, which is just that breed, favorite buttons, vote buttons, kind of card, as well as nav item and a main nav. We have a favorite and a vote store, and then our views consist of that home page, an image view, which is basically just a container with a heading, and then a router view underneath that switches between the image list, which is that list of dogs, and the pagination, and image details, which is that one large picture with the card underneath. So the first thing I like to do before writing even a single full test is to kind of scaffold out all of my tests. And so we would write all of the describe/if blocks based on user behavior. The describe blocks are for various conditions, and then the if blocks demonstrate expectations under each condition. So for the nav item, which looks like this, this would look something like this, where we would write out it renders an icon, it renders a title. Our condition is when the nav item is active, it is underlined and has a darker background, and then another condition when it is not active is it is not underlined and has the same background as the main nav. Our image list, before we get data from the API, we show a loading indicator, and so we will write describe before data has loaded, it renders a loading indicator. If we had more expectations for before the data has loaded, that would also be in this describe block. Our table. When data has been loaded successfully, it renders a table row for each dog returned from the API and a header row, renders an image. If there are breeds, it renders the breeds. If there are no breeds, it renders unknown. And then when clicked, it goes to the details page. And we'll get to this when we actually fill out kind of these tests, but when a row is clicked, we don't really care about what's on the details page in this unit test, we just care that it goes to it. The details page will be tested in a different test. Our pagination component, this is actually an external component from Lob's UI component library. It has its own test to make sure that it shows all the things it's supposed to show and do. So our tests for this, in this application itself, are going to be a little lighter than they would be otherwise. So when data has been loaded successfully, still continuing that describe block from before, pagination renders. When the next page is clicked, it changes the URL to the next page and calls the API to fetch the next page of data. And so again, we're not testing that if it's on the last page, the next button is disabled, because that's the responsibility of the component itself. And then something to note here is that the current page is controlled in the component state itself. So instead of checking that the state value is the page number that we'd expect, once again, not wanting to test implementation details, we're testing what a user would actually see in their browser. And then the error state, pretty simple. When there is an error loading data, renders an error alert. Again, if we wanted to do more things on the error state, those would go here. All right, our image details component has the same loading state. We'll have the same test for that. The header, image, and breed. So when data has been loaded successfully, it renders a heading with the image ID, renders the image. If there are breeds, it renders the breeds. If there are no breeds, renders unknown. Same kind of as the image list. Favorite section. So now we get into some buttons and some interaction here. It renders a favorite button, renders a delete favorite button. If the image hasn't been favorited, it should show not favorited. Favorite button should not be read, and the delete favorite button should be disabled. And so you can kind of see here that it's very easy to follow kind of what the expected behavior is for someone who may not be familiar with your app, and there's kind of a jumble of code in there. Lays out all of the kind of user requirements. And then describe clicking the favorite button. It should call the API to favorite the image. And then same idea for if the image has been favorited, just kind of different conditions under there, or different expectations under there. All right, our vote section. So renders upvote and downvote buttons. If the image hasn't been voted on, it should show the not voted text. The upvote button should not be green, and the downvote button should not be yellow. And then likewise, if the image has been upvoted, it should show different text. Button should be green. Hasn't been downvoted, should show downvoted. Downvote button should be yellow. Clicking the upvote button, it should call the API to upvote the image. And clicking the downvote button, it should call the API to downvote the image. Same as the list state, or the list component. Our error state just renders an error alert. All right, now that we've got our test outlined, how do we actually fill them in and start testing behavior? For that, we'll utilize a few tools. So at Lob, we use these three: VTest, VTest utils, and testing library. VTest is a test runner, has almost the exact same API as Jest, which makes kind of replacing Jest, if you wish to do so, fairly easy. Provides test coverage tools, JS DOM for DOM mocking, and has a super fast, super cool watch mode that I really like. VTest utils provides a mount function, which provides utility methods that you can interact and declare things on your UI with. And we'll get to this last point in a second. Testing library is a DOM testing library specifically made for UIs. It provides selectors, get by, query by, find by, that all do different things. We'll talk about those in a second. It provides fire event and user event to interact with your DOM, just DOM matchers to make assertions. And then testing library is actually built on ViewTest utils under the hood, and so they play really well together. So ViewTest utils provides a mount function that returns a wrapper object, which we'll look at in a second. When Googling around for Vue unit testing, this is kind of the most basic setup you'll find, and probably the most likely version you'll see of Vue unit tests. Testing libraries render is built off of the mount function. It returns some wrapper utility methods, but not all. So the question then is, why use it over the native mount? And it supports mocking a whole lot of stuff that you'll probably want to mock really easily, and then returns an object that can be destructured to access utility functions for querying for elements. And so this is an example of kind of that, again, basic wrapper utility. And so you'd use wrapper.vm, wrapper.find to find elements in your DOM, .trigger to trigger various events, There's nothing wrong with this. We just find it slightly easier to use ViewTest utils and the testing library in conjunction with what it already does. So let's talk about kind of what the other things provide us as well. Testing library provides getBy, queryBy, and findBy selectors. getBy returns a matching node and throws an error if no elements match. queryBy returns a matching node and returns null if no elements match. And so if you're asserting that something doesn't exist in the DOM, you'll want to use queryBy because getBy will throw an error regardless of like if the test is passing or not. findBy returns a promise which resolves when an element is found. The promise is rejected if no element is found after a certain length of time that can be configured. And so if you're wanting to select something that only exists after, for example, an API call is made or a button is clicked or something like that, you'll want to use findBy because it doesn't immediately exist in the DOM. Fire event and user event, both are ways of interacting with your UI through unit tests. Fire event is built into the testing library and it will dispatch exactly the events you tell it to, even if those events can't be dispatched in a real browser interaction. And so what that means is if you have a disabled button or a hidden modal or something like that that can't actually be interacted with, Fire event will still interact with that event as if it could be. User event is built on top of Fire event, and it tends to more realistically simulate user interactions. And so if you have a disabled button, it will not be able to click on that button. Sometimes I find myself wondering why user event isn't working, and for kicks and gigs, I'll drop in Fire event and then it suddenly does. And that usually tips me off to that my element is uninteractable in some way. JustDOM is a companion library for testing library that provides a variety of custom DOM element matchers that make asserting on elements really easy. And so they include things like to be disabled or to be visible or to contain HTML, lots of different things. Great, okay. So now that we've gone through kind of the tools that you can use for testing, we're gonna go through some real life tests. And for the sake of time, we're going to kind of cherry pick test from both the image details and image list components that we talked about previously. They'll provide a variety of things that you may encounter while writing your own unit tests, such as mocking the router, mocking the API, making API calls, and interacting with those elements and having things kind of appear. So the image details is a bit more UI heavy, so we'll focus on those first. First, we'll want to mock some things so that our test has access to everything that our component actually does. And so we'll mock the router. We only need to use route in this component. If we needed to use router as well for something like router.push, we'd have to mock that too, which we'll see in a little bit. And we're mocking the initial store with empty arrays with the Pina testing module. Mocking API returns. These are based off of actual API return values, and by that I mean I just copied and pasted them. I like doing this because it serves as further documentation if someone wanted to see what an API return would look like, what you're expecting it to look like. And don't want to open Postman or go digging around the network tab. So here we're mocking an image return. And then mocking a favorites return, which is just an array of objects of each favorited item. Mocking upvotes, which again, array of objects, value of 1 is an upvote, value of 0 is a downvote. All right, then we have something that looks like this, which is kind of a strange looking line. So this is a render component utility that we've created. We have a lot of global things in our application, from a custom UI component library, internationalization, constants, a dates plugin, a number formatting plugin, segment for analytics tracking, and so on and so forth. It'd be annoying to have to pull each of these into every one of our test files. And so we've created a wrapper to wrap all of the things we use in that render function to be available to tests. This is built on top of testing libraries render. That's what VTL render is. And then we can inject our components, the internationalization plugins, dates, format plugins, etc. Segment mocks, and then the user can also pass through any other plugins and mocks that they need. So this is what that looks like in practice, where we just declare a const of render component, use that render function, pass in our component, and then any other additional plugins or mocks that we are using. So actual test now, after the setup is done. We are mocking the API request to get a single image since we don't want to fire off actual API requests. Again, leave those to your integration or end-to-end tests. So the render component function returns an object that contains those selectors we talked about from testing library. We're getting the loading indicator by test ID, and then expecting the loading indicator to have attribute of aria busy true. We're able to use the get by query here because this happens immediately when the DOM is loaded. From here on out, though, we will be using find by almost exclusively because, again, those elements don't exist when the DOM initially loads. So when data has been loaded successfully, renders the heading with the image ID. We can use find by role here to find an element with the role of heading and an accessible name of image, and then our mocked data ID, and just expecting that to be in the document. Renders the image, since it's only one image on the screen, kind of taken a shortcut here and just use the image, and then declare that it has an attribute of src, and then the URL that's returned from the API. If an image hasn't been favorited, should show not favorited, and so we're finding by text and expecting it to be in the document. If the favorite button should not be read, we're looking for that button with find by role and the accessible name, and declaring that it should not have the class of those red items, those red classes. And then the delete favorite button should be disabled. So again, finding that button and then using that JustDom matcher to assert that it should be disabled. And so this makes it, again, JustDom makes it really easy to kind of assert these very specific things. So if an image hasn't been favorited and we click the favorite button, we can write a test for it should call the API to favorite the image. We need to mock the API requests that get fired off when you click the button. And so that's the favorite endpoint and the find all endpoint for the favorites module. And then find that button again. We're using user event to click on that button and then expecting that favorite endpoint to have been called with the image ID. All right, the image list is a bit more API heavy, and we're also going to have to mock that router.push this time. So just to remind you what that looks like. So the setup for this file is very similar to the image details component, except that we need a little more from our router mock this time. We need a query object because that's what the component uses to detect what page it's on, and then a router.push. And so here we're mocking that router.push with the use router and then push mock. We'll also need to mock the API return. That's more representative of what we get back from the find all endpoint. And so we have an array of objects, each representing a dog with a count key that is also returned of just how many images were returned. And so when data has loaded successfully, it renders a table row. We are mocking that find all so that we have access to all of those dogs. It renders a table row for each dog returned from the API and a header row. And so we can find all by role, which each has a row role on it, and expect the length to equal our data return plus 1. And then when a table row is clicked, it goes to the details page. And so each row has a test ID on it. So we're finding the first row based on that ID, that test ID. using user event to click on the row, and then expecting push mock to have last been called with, and then the new URL that it goes to. Eventually, there will build up a little array of things that push mock has been called with, and so we want to use to have been last called with here to find that exact one. And again, we don't care what's on the details page here, just that it goes to it. Again, what's tested in the image details should be tested in that component, and then in your integration and end-to-end tests. So here's what our pagination function looks like. It essentially takes a page number, it pushes to a new URL depending on the page number, and then calls the API for the new page data. You don't need to worry too much about this, but it provides some context for these next few tests. So our paging is set to 10 dogs per page in the component itself. So in order to fake having multiple pages, we're taking the first dog in our mock return and then just creating an array of 11 of them, just for the sake of testing. So when the next page is clicked, we need to mock that find all again with our new array of 11 dogs. And then it changes the URL to the next page, and so we find that next page button in our pagination component, use user event to click on it, and then again, expecting push mock to have been last called with, and then the new page number. And then calls the API to fetch the next page of data. This is a little funky here because our API is 0-based, but our pagination component is 1-based, so there's some funkiness with like finding the actual page number. But same idea, we go to the next page, and then we expect images API.findAll to have last been called with an object containing the new page number. There's going to be a lot of other situations you'll encounter that you'll need while testing that we haven't covered, but I hope this at least gives you a good start. Where to find all of the things. Again, slides are available at tinyurl.com/viewconf unit-testing. The demo app is deployed on Vercel. Demo app's code is on my GitHub, and then I can be found on the interwebs on Twitter, GitHub, LinkedIn, and my out-of-date website that I will fix soon. Thank you.
Amazing stuff, Beth. Well done. Does anyone have any questions? We got like time for like 2 very short questions, but like put your hand up very fast. You got 5 seconds. 1, 2, 3. Oh, you were good. Okay, question over there. I think we only have 1 mic, so I'm going to run, and I will pass it. I'll go this way.
So you were taking JSON data and copying it into the test. But with large apps, I found that to be very cumbersome. But with other languages, for instance, like Ruby, we could use a gem called VCR to, when we run the test and you hit an API request, it would prompt you, oh, do you want to record this request? We don't have this cached. Do you know of anything like that on the JavaScript side where we can just kind of automatically pull in and cache those API requests?
Yeah, I do not. That sounds very handy though, so if anyone does know a JavaScript version, let me know. But yeah, we usually just kind of have an external file that we keep all of our mocks in, and that's what we use.
Okay, excellent. The other question's here, and this is the last one.
Thank you so much for the talk. In a bunch of the tests, you were destructuring some of the utility methods off of your render component function, like find by or find by role.
Yep.
Is there a reason you're not just directly importing those? Is there an advantage to destructuring those from the render method?
Yeah, I wouldn't say there's necessarily an advantage. It's kind of just a pattern that we've gotten into. Allows us to kind of keep that import block, which is already large enough, down a little bit, but you could do that too.